Okay, so we're just going to go over more questions based off of this. The first part of the test is classifying numbers. And again, these words, whole, integer, rational, and irrational, they're not going to be provided, so you need to know them. And what's it going to look like? Number one, classify. Let's all jot this down. Let's do a different one. How about the square root of 6? Could you actually do the square root of 6 and get a nice answer?
Oh, no.
No, you can't. Right? If you do that on a calculator, you're going to get a crazy decimal that is infinite, doesn't have a pattern, so those are called irrational. Okay, let's do one more classification. How about a nice and easy one, like, and hopefully you guys are copying this down. How about a 2.4?
Rational.
What do you guys say about that? That's definitely rational. Again, any decimal or any fraction is a ratio, which means that it's rational because the word ratio is inside the word rational. So let's move on to the next section. Let's do a couple of comparing, or just maybe one, I don't know, comparing numbers, and we're going to have different types of numbers. It says right here comparing integers, comparing fractions, comparing percents, percent to a fraction. Let's do one of those, comparing a percent to a fraction. So like let's do number 3 here. And let's compare the number, or the percent, 32, let's go 32 this time, compared to 7 over 25. And 32% compared to 7 over 25, we need to think about which one's bigger. Is 32 bigger or 7 over 25 bigger? Now, you can't really compare them yet because they're not the same type of number. Okay, so you either make them both percents or make them both fractions. What do you guys say?
Fractions.
Fractions. Okay, the word cent means 100, right? 100 cents in a dollar, 100 years in a century, 100 centimeters in a meter. So the word cent means 100. So when we say 32%, that means 32 per 100. And we know, based off of these notes right here, when you're comparing fractions, you need to get the same denominator to compare the numerator. So, whoa, that got crazy. Sorry. Anyway, that 32%, we're going to compare it to the 7 over 25 by multiplying by 4, top and bottom. That way we'll get 28 over 100. And now that you have the same denominator, 100 and 100, we could compare the numerator 32 and 28. And which one's bigger? Obviously, 32 is bigger than 28. So the correct inequality symbol is the greater than sign. It's opening up to the 32. Okay, so we're going to have some of those. Let's try one more comparison of fractions. Nice and simple. 1/6 and 1/3. Which one is bigger?
1/3.
1/3. 1/3 is bigger. Yeah, if you change the 3 to become a 6, you'd have to multiply by 2, which means that you really have 2 over 6 compared to 1 over 6. And the 2 is definitely bigger than the 1, so it opens up that way. Okay, so there's just more practice, more examples of exactly what you're going to see on the test tomorrow. Let's go back to our list of the description here. We're also going to have to do a couple where they ask you for a decimal approximation, So let's try that. Let's give a couple of decimal approximations. Oh yeah, by the way, it says right here, it tells you create a perfect square number list, 4, 9, 16. Again, that's 2 times 2, 3 times 3, 4 times 4, 5 squared, 6 squared. You create this list, and then you use it to approximate those irrational square root values. So let's try one together here. Let's do the square root of 37. Yeah, square root of 37. What do you think that would be as a decimal approximation? Now I said create the list. I'll do the list right here. What's 2 times 2? 4. 3 times 3, 9. 4 times 4, 16. Okay, so as we could see, the 37 is right between the 36 and the 49, and it's not perfectly in between. It's really close to 36, right? So when we think about the square root of 36, we need to know that that answer is what? That answer is 6, which means that this guy is just a little bit more than that answer. So that should be roughly 6.1. Make sense?
Yeah.
So you got to think, where does your number land? Is it really close to a number? Is it perfectly in between two numbers? Is it right before a number, right after a number? So using that perfect square number line really helps. Let's try one more. How about the square root of 72? Square root of 72. So I've made a perfect square number list, 2 squared, 3 squared, all the way to 81, and that I could stop right there because I know 72 is right between 64 and 81. So 72 is not really close to 64, just like 72 is not really close to 81. So it's kind of like in between the two. So if you think about that, the square root of 72 is going to be perfectly in the middle between the square root of 64 and 81. Now, what is the square root of 64? That's 8. What's the square root of 81? That's 9. So perfectly in between, that's about 8.5. Okay. Now, it's not exact. It's just an approximation, right? Más o menos, the square root of 72 is 8.5.
Does that have to be exact?
No, this is an approximation. Right? So obviously, there's going to be more of those. It says right here that the decimal approximation, we have 4 of them, 12, 13, 14, 15. The next section, 16 through 21, adding and subtracting integers. That's my favorite because, in my opinion, it's so easy. All I have to do is think of money. So let me just create some random adding and subtracting problems. How about like negative 3 plus 5? How about like negative 6 plus 2? How about like negative 2 plus, let me do this, negative 5, negative 2 plus negative 5. How about, let's go with the negative 3 minus a negative 7. And one more. Let's do, a couple more. Let's do negative 5 minus 2. And negative 8 minus a negative 3. Yes. A bunch of problems. Let's go. What does this mean in terms of money? You owe $3.
Wait, no.
What does positive 5 mean? You have $5. You owe somebody $3. You have $5. Can you pay them off?
Yeah.
Absolutely. What's the answer going to be?
2.
It's going to be 2. You have 2 left over. The next one. You owe 6. You have 2. You still owe 4. If you owe somebody $6, you only have $2, you can't pay them off.
Negative.
You could give them the $2 and say, hey, I still owe you 4. So that's why it's negative 4. How about this guy? We owe and we owe, so we're going to owe some more. That's right, negative 7. Right? You owe 2, you owe 5, you owe 7. So guys, on this section, don't rush through this. Take your time and think about it. Use the words owe and have. Okay? Now, before thinking of money on the minus minus, you have to change it to plus plus. Now you can think of money. So right here, you owe 3, you have 7. You owe somebody $3. Could you pay him off if you have 7?
Yeah.
Heck yeah, you'll have money left over. $4 left over. So positive 4 is your answer. Okay? And honestly, this is the biggest part of the test right here, adding and subtracting. The next one.
Is there more adding and subtracting than division?
Moving on. This next one, you owe 5 because it's negative 5. And right here, you also owe 2 because a minus or a negative, either one means that you owe. Unless you have them right next to each other, then you change them to plus plus. But that means that you owe 5. This means that you owe 2. So again, you owe 5, you owe 2. How much do you owe?
Negative 3.
How much do you owe? If you owe somebody 5 and you owe somebody 2, you owe them a total of $7. Okay? Again, this is too easy to mess up. You got to go slow. Think about having and owing. A negative means you owe. A minus also means that you owe. Now, of course, you cannot think of it until you change the minus minus to plus plus on this last one. Don't think of money until you do this. Now you can think of money. What does this mean? I owe $8. What does plus 3 mean? You have $3. You can't pay them off. You only have $3. You owe them 8. You're still going to owe them 5. That means negative 5. You still owe them 5. And that's like the biggest chunk of the test, adding and subtracting positive, negative numbers, almost exactly like this. Let's move on to the next section. The next section is multiplying and dividing integers. So we have a good 4 or 5 questions on multiplying, dividing integers. Let's do some of those examples. So here are some examples for multiplying or dividing integers. Nice numbers, no decimals, no fractions yet. So what do you guys say? What's the answer to 2 times negative 3?
-6.
Negative 6. You have to put that negative. Again, if you're confused with the signs, with the rules, yeah, we know that negative times a negative equals a positive. If the signs are different, your answer is negative. So right here, a good thing happens to a bad person, that's bad, right? Right here, a bad thing happens to a good person. What's that?
Negative.
That's bad also, right? And it is negative. 20 divided by 4 is 5, so negative 5 is your answer. Okay. How about negative 6 times negative 2? 12. How about negative 6 divided by positive 2? Negative 6 divided by positive 2. Negative 3. How about negative 2 times positive 5?
-10.
Is this easy or what?
Yeah.
Are we going to ace this thing?
Yeah.
We better ace this, all right? Let's move on to 27, 28. And of course, if you're watching this for the first time at home, hit pause, copy down what you need to copy down. Let's move on. So we're down to pretty much the last 4 questions of the test here. Let's look at, let's give some examples for 27, 28, which is multiplying fractions. And I believe on the test it'll be 1 multiplication of fractions and 1 division of fractions, which is the same thing because you flip it and you change it to multiplication. Anyways, multiplying fractions is easy. You simply multiply the top with the top and the bottom with the bottom. So let's give an example. How about that? 1/3 divided by negative 7/9. You change to multiplication. So this division right here is going to change to multiplication. And then we do the reciprocal of the second fraction only. So it's going to be 9 over 7, but it's still negative. And the 1/3 does not change. The 1/3 just comes down. And now that we have a multiplication of 2 fractions, it's easy. You just do the top with the top and the bottom with the bottom. However, if you could reduce first, ladies, if you could reduce first, I recommend doing that. For example, we have a 9 up on top and a 3 on the bottom. Both of these are divisible by 3. Now, the 9 and the 7 you can't reduce, the 1 and the 7 you can't reduce, but the 3 and the 9 you could reduce by 3. So check it out. 3 divided by 3 is 1. 9 divided by 3 is 3. So there's my new numbers. And now we simply multiply the top 1 times 3, we get 3. And the 1 times 7, we get 7. And of course, yeah, the positive, this is a positive one, times a negative. If a good thing happens to a bad person, that's bad. Okay, yeah. So yeah, I saw the 9 up on top originally and the 3 on the bottom. So I could reduce 9 by 3 and the 3 by 3. So I reduce both by 3. That's how I get the 3 up here, and that's how I get a 1 down here. That's called reducing. You didn't have to do that. You could have just multiplied top with the top, bottom with the bottom, and then reduced. But either way, you get this answer of negative 3/7. Let's try one more. And again, if you need to pause it so you can have more time when you're watching this at home. Let's do one more. How about, let's try negative 12 times negative 3/4.
That becomes negative 12 over 1.
Yeah. Multiplying fractions is easy, and you probably,
12.
let's put a 1 under here. And you could multiply top with the top, bottom with the bottom, and then reduce, or you could reduce first, then multiply. So I'm going to reduce first, then multiply. Why? Because I know that 12 and 4 are both divisible by what?
3.
By 4. Right? 12 is divisible by 4, 4 is divisible by 4. So I'm going to reduce by 4. So 12 divided by 4 is 3, 4 divided by 4 is 1. So what do I really have right here? I really have negative 3 over 1, that's just negative 3. And over here, I really have negative 3 over 1, and that's just really negative 3 also. And we are multiplying between the two, so I need to put the multiplication there. And a negative 3 times a negative 3 equals positive 9. A negative times a negative is a positive. Anybody get confused with that? Okay. Do you guys want a different approach at it? We could do a different approach. Check it out. Let me rewrite this problem. Okay, I want to rewrite that same problem. We're going to do it slightly differently. It might help you. I don't know. We had negative 12 times negative 3/4. Okay, and you put the 12 over a 1. Everybody understands that, right?
Yeah.
Now you could, if you wanted to, just multiply negative 12 times negative 3. What's 12 times 3? 36. And on the bottom, what is 1 times 4? 4. You could do that. See, up here, I reduced first and then multiplied. But you could multiply first, then reduce. Again, a negative times a negative is a positive, so we don't have a negative sign anymore. And right here, what this really says is 36 over 4. Now you could reduce that. You could reduce it by 2. Or you could say, hey, 36 divided by 4. What is 36 divided by 4?
9.
It's 9. So you get the same answer. So it's totally up to you if you want to reduce first, then multiply, or maybe multiply first and then reduce. It's up to you. The last two questions are dealing with exponents. So negative 5 squared is what?
Negative 25.
Good. Negative 25. Now, where did that come from? A lot of people say, no, it's positive 25. No, it's negative because there's no parentheses included. So if I did have negative 5 squared, then that really would be negative 5 times negative 5, and that would be positive 25. But in this case up here, we don't have the parentheses around the negative sign. So right there, it's really negative 5 squared, and then the negative, you place it out in the front. Okay, so let me give another one here. How about negative 3 squared? What's the answer there going to be?
Negative 9.
That's going to be negative 9. Once again, the 3 squared is 3 times 3. And the negative sign, you just put it in front, which means negative 3 times positive 3, that's negative 9. So that's our answer. That's how we do those. Now let's compare that to one that does have parentheses. How about there? Negative 2 to the third. Are we including the negative sign? Yes, because the parentheses are there. So when you expand it, negative 2 times negative 2 times negative 2. Guys, yeah, show your work and group them. Negative 2 times negative 2 is positive 4. And then you bring down the other one times negative 2. So positive 4 times negative 2, that does take you to negative 8. Should we try another one or are we good? One more.
16.
Negative 2 to the 4th power. Let me expand it so I can show my work. And I would pair them up. Negative 2 times negative 2? 4. Positive 4, right? Negative 2 times negative 2? Positive 4. What's happening between the 4s? Multiplication. What's 4 times 4? 16. Done. I'm telling you guys, watch this video again. Watch yesterday's video again. You should ace the test tomorrow.